Well, good evening, everybody. Uh, Chris at Elliott Astro Imaging, probably not imaging tonight because he has smoke and clouds just like I do. Well, I have smoke, not clouds, though. Uh, we have forest fires within 100 miles of us, and a couple others, one down south 50 miles from us. And the sky is really thick with clouds. And so I thought what I would do tonight is just show a little bit of how I go about setting up my imaging session, talk about some of the software I use and what it does. And as you can see on the screen, what you see there is my imaging computer screen. I use Windows exclusively and remote desktop into the computer. So one of the first things I do is I set up my software, and the first one will be PhD, which is the guiding software. And PhD stands for Push Here, Dummy. And it was designed to help people easily guide on their astro images so that you can take longer exposures. And the first thing that you have to do is, of course, connect your equipment. I'm using a Orion Starshoot auto guider camera, so I can connect it, and it will connect up. Believe me, I know what. I got 2 steps ahead of myself. Let's close that. I also use a Pegasus power box, and this box allows me to turn off the USB ports or turn them on as I need them. I can control the power. This first one is for the camera cooler, so that I can cool the camera down to -10 degrees to get rid of thermal noise. This one here is for the autofocuser. Now this one here is for the mount, and the mount has got some sort of heavy relay in there because I can hear it click. And since I'm using a current limiting power supply, it sees that spike and shuts down. So when I click this one on, in a moment I should get a box right there. See, it says lost communication with device, and that's because the voltage drops down below 10 volts and the box disconnects. And that's just an instantaneous. I mean, you'd have to see it on an oscilloscope to actually see it. Then on the data, I go ahead and turn on all the USB devices. And back in the power here, down here where you see in the mouse, these are for the dew heaters to keep the moisture off the lenses. If I click this button here and set it, now it will automatically turn the dew heaters on when the temperature gets down within about 3 or 4 degrees of the dew point. Right now we're at 23 degrees Celsius, which you metric people can help me out there. It's somewhere around 75 or so, I think. I could calculate it mathematically. And the dew point's at 8.4 degrees. So we got a large spread, so these won't come on for a long time. Also in the power box, we can monitor the voltage and we can monitor the current. Here's that spike where the first things came on, and now they've kind of leveled off. Actually, this is from yesterday here. Over here is where it just come on right here. And so you don't see that spike in the voltage that I was talking about earlier. So that turns everything on. Now, whoops, I hit the wrong button, didn't I? Now I can come down to PhD and turn that on. And we'll go to the equipment. Now I can just press connect all, but I want you to see different things. You see them one at a time. I hit the connect button now, and pretty soon that should go to, come on, disconnect. So that means that the auto guiding camera has been connected to the system. Here's the mount, so I'm connecting to the mount, and that pulls up some software called EQ ASCOM. And what this does is it kind of coordinates the talking between the different programs that need to talk to the mount. PhD needs to send command guiding pulses to the mount. My planetarium software needs to tell the mount to slew to different places. And the imaging software, as we'll show later on, also needs to talk to the mount. So that's what EQASCOM does. It takes these commands in and just kind of shuffles them. There's a button down here that is for unparking the mount. We'll get to that in a little bit. So this part is set up. So now we have to come down and turn the camera itself on. And that's done right there. And there's the image. That is the sky right now. You probably can't see that too well on the video, but there are some stars there. Let's see if I can brighten them up any. Nope, that washes them out. Anyhow, there's some stars there. If I click this little yellow star down here, that will tell the program to pick a star up here to guide on. And it'll usually pick one around the edges. For some reason that works better. It has to do in the algorithms, and I don't understand it. I just read it and I accept it. But we're not going to guide on those stars because that's not looking at anything really. So we shut that one down. The next one I load up is my planetarium software, and what I use is Cartes du Ciel Sky Charts. And this is a freeware program that don't remember the guy's name. I read it every time too. But that will give me the planets, it'll give the planets, some stars. It'll give all the galaxies and things like that. Right here, this is the same one that Chris is using. And of course, I come up here to telescope, hit that, connect telescope, and just hit connect, and you see that turns green. Now you note the tracking is still red because the tracking hasn't been turned on because the scope is parked and not ready to move yet. So that gives that. And then the program I use to image with is one called Astrophotography Tools, and it's got a whole bunch of tools built into one program.
Camera connected.
You could probably hear that. Said the camera automatically connected.
Telescope connected.
The telescope connected.
Focuser connected.
The focuser connected. And when I get my filters and filter wheel, it will automatically connect the filter wheel if I want it to. This little window here is the cooling aid. You can set in here the temperature that you want it to go to cool to, and I usually use minus 10 degrees. The cooling in the camera will cool it down to 45 degrees below ambient temperature. So if it's 45 degrees centigrade outside, it will cool it down to 0. And I cool down to 10. If I look at the charts on the cooling, the noise figure, I don't gain anything by going much below 10. And the cooling, what that does is it helps eliminate some of the electrical noise that is generated within the camera as the camera heats up taking pictures. So we'll go ahead and hit the start on that, and it will, what it will do is it will drop the temperature down in steps, in 7-degree steps, and it'll pause and then keep on going so that you don't get thermal shock onto the image cooler all the time. And it just helps extend the life. I'm not sure it's 100% necessary, and I had spent my life in electronics working on things like this, so that's just kind of my educated kind of guessing thing. But it's there, I use it. Now the next thing I do after that while it's cooling down is I use a program called PolMaster, and it's by QCHY cameras. And what that does, normally to polar align a telescope, and for those that don't know, polar aligning a telescope is getting the axis of the telescope, the rotational axis, in line with the North Pole axis of the Earth. And you do that by aligning on Polaris, which is close to the celestial north. And so to do that, what I do is I connect the scope here. And as you can see, there's some stars here. This bright one is Polaris, and I know that because I've been using this all week, so it is close to polar aligned, close enough that I don't need to worry about it. But I'm going to go through the steps here just to show you. So it says set the parameters to make more stars around Polaris visible. Well, I can bring that up a little bit. There we go.
Deep sky clock event closing.
I'll explain that later on when we get back into astrophotography tools. Because of its early twilight here, well, I guess we can see a few more stars. I don't know if you can on YouTube there. But here's Polaris, so I've set the exposures I need, and now I double click on Polaris. And you see this little graph that comes up. Well, since Polaris is not actually at the true celestial north, it rotates around the north. I think you can see this little X right here in the center. That is true celestial north, and Polaris will actually rotate around that during the day. And so now we have these stars, these circles here that will line up with some of these stars, and we do that by moving this slider here. And you got to go kind of slow because it moves real fast. And okay, so you see I've got, let's see, I've got a star here. You can just barely see that one. I can just barely see that one, so I don't expect you to see it on the screen. There's one down here, one here, and one here. So those are all lined up. So once we've done that, we say success. And this comes up. This is do I want to use the same information I recorded last night? Well, I'm going to click no so that you can see what the whole thing looks like. So I'm going to click no. So now it says choose a star other than Polaris. So we'll pick this one here. And rotate the mount about the right ascension axis at least 30 degrees. Well, I'm not very good at guessing what 30 degrees is, but everything I've used has worked. So this is the EQ mod program that we opened earlier. I'm going to unpark the scope. And right here, I can control the speed of the scope on how fast it will slew. 1 is a really slow rate, and so I'm going to move it up fast so that I can hit this, and we'll watch.
Cooling finished.
Let's see. We'll watch this star right here. I clicked on this one here, so we'll watch that move. And you probably heard in the background that the cooling process is finished already. So you see that star has moved considerable distance, and so we'll finish it, and that'll say double click on the same star. So we do that again, and we do the moving again. And what this is doing is it's calculating where the rotational field of the telescope is in reference to true north. And we rotated it, finished. Now we'll double click it again. So now this green circle comes up, and we're going to park the scope to put that star back where it began. And what we do is we watch the tracking of that star on the circle here to make sure that something isn't out of line and we're not getting a true smooth circular rotation. So I'm going to hit the home button here. That sends the mount back to the park position. And I don't know if you can see it on the screen there, but here's the star right here, and it's tracking right along that green line, just like it's supposed to. Okay, and it stopped, and there, the mount is parked again. Okay, and that's correct. So now we double-click the Polaris, and I don't know how this is working on the screen there. This is my first shot. I won't know until I watch the video. But there's a circle around Polaris, and then next to it there's a little dash circle that's kind of rotating, and it has a plus sign in the center. That plus sign is where the direct rotational point of the mount is, and what we need to do is move that over to being on Polaris. Well, that's where it's at is close enough. I've done imaging last couple of nights, and the tracking is good, so I don't need to worry about that. So, and then it has you make sure that the stars are aligned within the circles here. And now we hit this one, and I think you'll be able to, let's see. So what we do now is we would take the altitude and azimuth adjustments of the telescope and adjust Polaris over to the center of that scope. Well, once it gets to here, you're pretty close as you can get because of the sensitivity of the movement. So we click finish on that, and we double click Polaris again and make sure the stars are lined up. A bunch of checks and balances here. So the stars are lined up, and we hit success. Now over here is the fine tuning. This is where you get in the real precision tuning. And so I hit that, and you see the little green box here? What I would do is I would use the altitude and azimuth adjust to get that as close to that red dot there as I can. And things like seeing condition, how much moisture's in the sky, how much turbulence in the sky, will at times make this thing dance all over the place. And that's what was happening when we first aligned it, and it was just bouncing all over, so we got it close enough. This is close enough for guiding. PhD2 guiding will certainly compensate for that. So we're polar aligned. The way we used to polar align was to look in the through the axes of the telescope with a what they call a polar align scope, and align Polaris that way. And it would take us as much as 45 minutes or so to align the scope, because I don't have the luxury of leaving it in the same spot in the yard all the time. I don't have a shed for it. So that would get us polar aligned. And like I say, with the polar scope there, you can see how much quicker it went. We can polar align now from start to finish in about 10 minutes at the most. So we're going to unpark the scope again, because we're going to try and move it. So I bring the star map up, and we'll pick on something here. And I don't know how good a picture we're going to get, because like I say, we do have a lot of smoke. I have a mountain range that's about 10 to 15 miles away from me that I can see normal days, and I can't even see the foothills to them right now because of the smoke. Here's M32, the Andromeda galaxy. And so what I can do now is I can just right click on that Andromeda galaxy like that, and the window comes up, and I come down here to telescope, and I can hit slew to M31. Now what I like to do now is come up and hit this anchor, and what that does is locks the view of the map to I'm pointing with my finger to the telescope right here, so you can watch the telescope as it's moving. As long as the telescope is moving, I know it hasn't snagged on any cables or anything. And I also have a monitor over here to my right that I can watch the telescope move on. So now we're on Andromeda, and so we're ready to actually take an image. So that's where I bring up the astrophotography tools. And if there's any questions, you can leave them in the comments sections, and I'll be more than happy to answer what I can. So our temperature is down to minus 10 degrees, and so we'll shut that off. This is astrophotography tools, and it's got a whole bunch of cool stuff that can be used. You heard the deep sky clock message earlier. Well, you come over here and open that up, and what it does is it tells you, like sunset, it will announce sunset. The sunset here at my location is at 1932, which would be 7:32 in the p.m. in the evening. It tells you nautical twilight when it ends, when astro twilight when they begin, and sunrise, which will be 6:41 tomorrow morning. It tells you the moonrise and the moonset. And down here, I don't know if you can see it. I hope you can. there's the DSD time. Well, that's deep sky darkness, and that's when the moon is down and the sun is down and below the horizon enough to where it's not affecting the sky at all. So the sky is as dark as it's going to get. And tonight at my location, it's 1 hour and 49 minutes. Now below that, they give us the narrowband time, and that's if you put a filter in, like a light pollution filter, or a H alpha, or what's it, O2 or O3. Anyhow, oxygen and sulfur, you put those filters in, you can get extended time, and that's 7 hours and 33 minutes tonight. Well, I have a light pollution filter in, so and it also tells you when it starts, and I try to do things in 24-hour time because I think it's cool, but my mind just doesn't work all the time. 2100 hours, I think that's 9:19 is when deep sky darkness starts. And right now, we're at 2036, so it's supposedly deep sky darkness right now. So we'll go ahead and close that. Now over here is the camera section. I'm going to disconnect the camera. You should hear the announcement through the microphone here. Oh, I can't do that. I've got the cooler on. I'll show you with the mount instead. If I did it with the cooler would shut down, and I have to go through the cooling cycle again. But we'll go here to go back to the camera. And down here you can set timed exposures. Right down in here you can see you can put the name of the object you're doing. First object I always do is a test, because I'm going to test the camera and exposures and whatnot. And I usually do like a 10-second exposure. I can set the I've heard it pronounced two ways, binding or binning, and what that does is that groups the colored pixels in the camera, so that instead of taking 4 pixels, the red, green, blue pixels, to make a picture, they use a group of the 2x2 binding would use 2 across and 2 down, so 4 sets of the red, green, blue pixels. It gives you a bigger coverage, but the definition isn't quite as good. I can do a region of interest where I can draw a picture or draw a square on the screen, and the camera will only download that portion of the picture, so it speeds the download time. And image preview. There's also a warming aid down here, and then there's some settings for the camera itself. So we go to the gear, and this is where most of the work is done. I'm going to disconnect the scope right now.
Telescope disconnected.
So if I'm connecting to a different type of scope or connecting for the first time, I would hit the shift button and then connect. And it brings up this window here, and from here I can select whatever mount is hooked up to my telescope. And so I use the EQ ASCOM HEQ5 mount. So I would click that. The first time I do it, it brings up the properties menu, and it's telling me that it's already configured, because that's the one I always use. So I go OK, and it will connect the telescope. And the same thing for the focuser, or here's the filter wheel for when I get it working. Haven't got my filters yet. And this is a rotator where you can rotate the camera to get the best angle of the camera on the object you're looking at. For instance, if you're looking at the Veil Nebula and it's straight up and down, and your camera's the imager is horizontal, well, then you could rotate the camera to where you get more of the object in it. Let's go back. Well, okay, I'll show you this here. They have an objects file here where you can pick an object. They have several thousands of objects in there, and they have the ability to show only the ones that are above the horizon for you. And I always have that clicked. So we're at M110. Now without the star chart, I could go to M110 right here, click on it. Oh no, excuse me, I almost messed up, didn't I? We're on M31, Andromeda. So I click on that, and then I could hit go to.
Deep Sky Clock event.
And if I bring the map up, you see that, scroll this in, oh come on. That's one thing about this program okay. I get backwards. Naturally forward is going to be scroll in. Okay. Oh, I've got company right now. Hang on just a second. I'm going to mute the mic for a second so I can take care of this. I think this one does it here. Nope, that one doesn't do it. And back with you. That's my 94-year-old mother comes in to say goodnight to me every night. We have 4 generations living in this house, and you know, pretty close. So anyhow, as you can see, the camera has moved off from Andromeda from where we actually had it, and that's because APT astrophotography tools and SkyChart are seeing things really a little different right now. So what we can do now, which is kind of fun, is we're going to take a picture.
Exposure started.
I hear that, and it tells you the exposure started, and this is I think that was a 10-second exposure. Yeah, 10-second exposure. And we've got 3 more seconds, 2 more.
Exposure finished.
And we should see a picture pop up right here. Momentarily. For some reason, my particular camera loads the picture real slow, downloads it to the program real slow. Other cameras I've used are lightning fast. So now we've got this picture here. We can go up here to PointCraft. And what PointCraft is a suite of tools that will plate solve this picture and tell me where I'm actually at. So I can do it one of 2 ways. I can either pull the location of the camera, or location of the mount, the data from the mount, or I can go to the objects and select it. Well, we'll pull the data from the mount. What that does, it sends a command to the mount. It says, hey, where do you think you are? And so the mount says, this is where I am. So I hit plate solve. And there we go. 1, 2, 3. I was hoping it would be really quick tonight. There we go. Come on.
Image solved.
Okay, so its image is solved. So now it says, I know where you really are. What it does is it goes out to a database and looks at all these stars, and they do some triangulation on it, and all that good math stuff that all those high-priced math people get paid for. And they say, this is where you are in the sky. So I come over here and I sync the telescope. And this sends the command from the program here out to the SkyChart program and the telescope and says, hey, here's where you really are. So we'll bring the map up here again. See this? See where the camera is right here? This is where the camera thought it was versus where it actually is. So what we do about that is we come over to the object, which was in this case was M31, right click on it, come down to telescope, and come over here to sync M31. And as soon as I do that, we'll get a window pop up says, please confirm that the telescope is pointed at M31. So I hit yes. And there it goes. It's on. Now you can see my camera is not really angled properly to get the most of Andromeda. That's where that rotator would come in handy, but those things are about $1,000. I think they good ones started around $6 and they go up from there. And so that's low on my priority list. So now we'll go back to the image program. And here's something that is really slick. I hit on the objects button here again, and I select M31, and I go to plus plus. And what that's going to do is it's going to move the mount to where it should be, right here. And now it's going to take another picture. What it does is it allows the telescope to settle.
Exposure started.
And how long that settle time is adjustable. And now it's taking an image.
Finished.
And now it's going to plate solve that image. And of course it's got to download it first. And we're solving now. I don't know if you can read that up. It says up in the corner over here it says solving, and then down here on the application it's okay, now it's moving the mount. And we'll come down here and look at the sky chart. Oh boy, that has moved a ways. And what it said is that the target is 30,872 pixels away.
Exposure started.
And so it's going to keep...
Exposure finished.
It's going to keep doing that until it gets it moved within 50 pixels. The object will be within 50 pixels of the picture. And this can take some time. Wish I had a pause button on this thing. I would pause it and come back. But since I'm live, I don't know how to do that. I'm new at this. So while that's doing, we'll come back down here to PhD 2. And I don't know if you saw that streak in there. That was as the telescope's moving. Now right here where the cursor is, when I move it, you'll see that little dot there. That is Andromeda.
Exposure finished.
I have my my spotter scope set up so that it's pretty close to the camera. And let's see. Okay, now we're within 497 pixels, and look at there. I'm pretty sure you can see that on the screen, on the YouTube screen. That is
exposure started.
Andromeda right there.
Exposure finished.
So this next time it should get it right on. Yeah, you can see that right there.
Go to plus finished.
Okay, so that did it. Now the other thing I can do here is sometimes the astronomical data for the object you're looking at, so say like M31 here, is not exactly in the center of it. Now, I don't know why. It's just the way it is. But you can take this button here. I hope you can see it. It says aim. You can click on that, come over here, and you can click on that star there. And now if I hit go to, it will move that to the center. For instance, on the Veil Nebula, when I did the Veil Nebula the other night, there's a bright star that they center right here for the Veil, but that leaves a little bit of the nebula off the camera. So what I do is I pick a star a little further away and I do the aim. It shifts it over just enough to where everything lines up. So there's how I get my objects located and centered. And now we go to PhD2 because we're going to actually start getting into the imaging. And PhD2, like I said, you hit the little yellow star down here, and it will automatically find the best guide star. And then we hit the guide button, and now it's guiding. And we'll come back and look at that a little better. My guiding graph doesn't look as good as Chris's does, but my pictures turn out. So now, since we have this done, we could go to tools here. There's some tools, a nice tool here. You need to get into a different view mode. And there's a focus aid. Now when you put this focus aid over that picture, it tells you what the full width half depth modulation is. And I read about it and I thought I understood it one time, but hey, if I don't use it every day, I lose it. The half field depth is they measure the peak of the star and figure that the half depth of it is the depth of it halfway is the center, and so they shoot for that. But anyhow, you would adjust these for the minimum value. And then what I would do is I bring up autofocus aid, and I would hit that, and it will run through an algorithm, and it will move the scope in, move the focuser in automatically to a certain point, take this number here, and then it'll move it again and take the number. If the number goes up, then it's going the wrong way, and if it goes down, then it's going the right way. And they'll keep moving back and forth until they get the best number, and then you get these nice round shiny stars in there. Now, my eyes are going bad, I admit that, and especially my night vision, because I am 70 years old, and things start happening about that time in life to some people, and that has been just a godsend to me. I spent a whole imaging session the other night. I imaged by I was having troubles with the auto focus, and I couldn't get it, so I tried focusing by eye, and the whole night was shot. And the problem was that I didn't get it. You need to get the focuser close for the focusing aid to be able to really take it and do it, and I hadn't done that. So now we can take pictures, and we got two ways of taking pictures. Like I say, we can come down here, and we can put in a time. I'm putting in 60 seconds here, but I don't think I'll shoot that picture because that would take 60 seconds of dead air, which I don't know if anybody really wants to sit through or not. I'll just go on to the next step that I do. See this section over here? It says plan. I can come down here and pick a plan. Well, let's do the edit first, because that gets a bigger picture. And here they have some plans to edit. And what they have is they have light plans, which the light plans are the image of what it actually is that you're taking a picture of. They have a dark frame plan, which is you take black pictures with no light at all, and that gives thermal noise and electrical noise in the camera as a picture that can be subtracted out of the image. And then you do a flat frame, which is just pure white light. And what that does is that illuminates any dust particles that are on the lens or anywhere within the optical train, and then the software can take and look and says, okay, those are dust particles, we'll remove those out. So these other frames here are just for enhancing the image. The bias frame is where you take it totally black, but you take it as fast as you can, and what that does is that tells the imaging software or the processing software what the read noise of the camera is, what noise is being affected just by reading the data out of the camera. The dark frames are taken at the same exposure as your light frames, so that the thermal noise is the same for both of them. So you process it out. Dark flats are something else. They're darks taken at the same exposure as the flats. Some cameras I hate to use the prefer for an inanimate object, but some cameras work better using dark flats than flats, and you have to kind of experiment around with your camera. So we're going to come up here and take deep sky, because that's my standard picture taking I take. Most of my pictures I take at 180 seconds, so I would change that. Here's that binding I was telling you about, binning. And then how much to pause between pictures. If you're using like a DSLR, like a Canon or a Nikon, as the mirror flips, it introduces shaking into the telescope imaging system. And so you can put in here like 100 seconds to wait after the mirror comes up before you take the next picture, and you get rid of that vibration. Since I am using a shutterless camera, I can put this at anything I want. I usually leave it at 1 because that's default. Down here is the number of pictures that I'm taking. Typically I take 20 3-minute exposures. At 20 exposures is an hour worth of picture to process. I find that tends to work real good, especially if I take several sections of them and then stack them all together. It works out well. Now you see I've changed the exposure here to 180 seconds. I've changed the count to 20 seconds, or to 20 counts rather. I'm going to change that back to 1, because I don't think I'm going to sit here and let you guys sit through a whole entire imaging session of nothing going on. And so since I've changed those, I have to hit the update. Now here's something I just figured out this last week with this thing that's just really cool. See the script command down here? If you hit that script command here, it opens up a window, and you can take and pick from some different things here. Like for instance, say the telescope is parked. You can click on unpark. Or since it's unparked, you can click on this. This is an image session here, so what we can do is click on guide control, stop the guide control, say OK, and add as new. Now what we need to do though is we need to go change our exposures to 0 so that it won't actually take a picture. Didn't know that when I was first playing with this, and so every time it did something, it would take a picture. And that was kind of, especially if I had the counts up at 20. So I leave the counts at 1 when I'm doing this kind of thing. So now what that'll do is after this session here gets through, it will stop the guiding. It will actually take PhD2, send it a command to stop this guiding here. And you say, well, what good is that? Well, then we come down here and we can select on, I got it, go to ++. Ah, look at this window here. It comes up and exposure auto. I use near solving, and it's got an objects field here, so we can select an object. Well, let's go down and select 110. We can select M110 because that's real close to Andromeda, and we can hit that again, and then we'll add that as a new one. So now we'll hit the script again, we'll come back, and we'll go to the guide control, and we'll put start and hit that again, and add as new. Now one thing I forgot to do is What was this one? Well, that was guide control stop. I didn't change that one to 0. And wait for command to end. Otherwise it'll just zip right through them, and some commands take some time to process. So I'm going to update the current. I'm going to take this one, change that also, update it, and this one here, that's the guide start. Do that, update it, and now we're going to go and I think I'll change these exposures so that there isn't a whole lot of waiting going along. 180 seconds, that's 3 minutes, is a long time just to sit and wait for nothing happening. We'll change this one to 30, and again 1 second, and we'll add that as new. Then what I can do again is I can come back here to guide and go stop, okay, and then script command, I can go here and park, okay, and I could actually go in now and I could run the let's see, tracking shutdown, maybe it's up, oh, CCD warm, and I can click on auto. Now what that would do is that would just automatically warm the camera and whatnot, but I'm not going to do that because I'll probably play around more after I end this. Let's see, so this one here is the guide control start. Okay, so now what we'll do is we'll do 30 seconds, one exposure, and we'll add that as new. And this one here, we're going to go ahead and change that to 30 seconds also. And I'll show you how this works because it's really kind of cool. So what it's going to do, it's going to take a 30-second exposure, and it's going to come down here, it's going to stop the guiding, and it's going to come down here and it's going to go to M110, and then it's going to start the guide control. Oh, I changed the wrong one. Let's take that one back to 0 again. And yeah, this is going to start the guiding again. We'll update that. Oh. There we go. And now we'll do another 30-second exposure. We'll add that one as new. There we go. That's where I did wrong. So what it'll do is it'll take Andromeda. It will take. It'll stop the guiding. Go to M110. Start the guiding, and then take another picture. So let's see how that works. Okay. And I wish I could. Get these up here at the same time, but I don't know if I can. I don't have that cool program Chris has. I think he called it Open Windows or something like that. Yeah. No. Whoa, that's too big. But you can see right here the guiding pulses, everything looks pretty good right now. So let's see, what did I do wrong? Maybe didn't expand it far enough. Yeah, I didn't expand it far enough. There we go. So there's our guiding. I think I'll leave this sit here. We're not going to see much at a 30-second exposure, so there really won't be much to see there. But you'll watch the green here after the.
Deep sky clock.
Oh, did you see that?
Closing.
Satellite or an airplane, one of the two. Probably an airplane. The way it blinked, that's the strobes going on and off. But you'll watch after it takes the exposure. When it says exposure finished, you'll see this crosshair disappear. And then you'll see these stars start blurring as it moves to the new location. So let's go ahead and quit talking and work.
Exposure started.
There we go. So at 30 seconds, you should be able to see the dot there. I think the other one was 10. I think that's a 10-second exposure. I have my plate solving set for 10 seconds exposure. It seems to get enough stars to do the job.
Exposure finished.
And yes, you can turn that voice off. It gets a little annoying because when you're doing a plan like shooting 20 photos, it announces every picture. Exposure started, exposure stopped. And it's going to...
Exposure finished.
Yeah. Okay, see?
Exposure finished.
The auto guide shut off. Over here you see that the point craft came up. It's, I don't know if you can read it here, but it says moving. Now it's settling. And each one of these steps here is considered an exposure. So
exposure finished.
And I haven't figured out how to use an error correction if it fails to plate solve, but it plate solved, and it said it's within 30,305 pixels again. So I do seem to have something not quite right between my sky chart and the astrophotography tool, but the plate solving. Yeah, the plate solving corrects everything. So
exposure finished.
So this is the like I say, this is the Go 2 plus plus moving it to within 50 pixels of center of the screen, center of the image sensor. Okay, we're within 361 pixels now. So
exposure started. Exposure finished.
So I hope you've enjoyed what I've shared with you tonight, because we're getting ready to wrap it up since our image is almost done. I'll do another video soon about how I process my pictures.
Plus finished.
Okay, so there we go. Now, come on. There we go.
Exposure finished.
Okay.
Exposure started.
Right there is the one that started, and there, now it's guiding on this location here. And we'll close this down, and just to show you that I shouldn't do this because I'll probably wind up something not working. This is going to be 2 minutes, so you're going to have to listen to me babble for a while, for 2 minutes while
exposure finished.
Okay. Yeah, what was... Okay, so we're guiding, and so I'm going to do a shoot here.
Imaging plan finished.
And that was all those steps that went through. That was a 30-second picture of M110 that it did. Yeah, that's right. So I don't think I'll go ahead and... well, I will. Somebody somewhere might want to see it, so I'll go ahead and do the whole 180-second thing. And I'll kind of babble as it's going along to hopefully...
Exposure started.
You won't fall asleep waiting for the picture to happen. But that's basically how I go about setting up with the Polar Star alignment. One thing about that PoleMaster is I can open that again anytime I want. and connect it up. There's Polaris right there. Let's double click on Polaris, and I can align the... Actually, I don't even need to do this. Whoops, I think I can go back, can't I? Yeah. I could skip on through this and get to the... because all I do is tell it success. And now it's asked me if I want to use the same data that I just put in. So I'm going to say yes to that. And it's going to ask me to double click Polaris again and align these up. But I can just hit success. It doesn't know that I haven't done it. And I can hit finished here and double click Polaris again. And here comes up the fine-tune screen, and I can start the monitor. And there you can see it hasn't moved any at all. Last night I kept forgetting to turn my guiding on, and I was shooting 3-minute exposures and didn't get very much star trail at all. I haven't magnified the images a lot. I haven't zoomed in on them a lot to see what it actually down in the magnification looks like, but just in a standard picture like this you couldn't see any star trailing. So I thought that was good. Disconnect it and shut it. So I can go out throughout the night. I can periodically check that if I want. Before I built my cart and put the feet on there that spread the load out, my telescope would actually sink into the ground over a period of a day or so. It would settle in, and my polar line would be off. And so I could check it like that, just real easy to see if it's happened. And I have babbled for 153 seconds now, so 30 seconds more and we'll have our picture. And it should be M110. And for those that may ask, this green background here, they use a real quick and dirty deburring process to show the color in the picture. And because there's two green filters on it, each section, there's
finished.
Red, green, green, blue. Well, you get a predominantly a green background, and we use software to take that out. And there you go. I know you can't see it, and you're going to tell me I'm smoking crack, but right here is M110. And the reason I know that is I've taken that picture recently, and one thing about this program here, like Chris can really stretch them out with his software. I can't really stretch them out all that much here. I've tried, and it just let's see. Let's see what that does. Nope. Yeah. I haven't played with it enough to really see if I can do anything, but it doesn't look like I can get near as good at pictures on screen as he can. But when I do my processing video, I'll show you, because I'll give you a sneak peek, okay? Let's see. I didn't want that one. Let's see. Let's go down here. And I can open up, this is the imaging software I use right here. It'll take a minute to open up, but yeah, there we go. It's called PixInsight, and it has a whole suite of tools in here to use. These are process icons. I'll go into this more later on in an in-depth video. So what I can do is I can open this up, and since I'm in my bedroom actually doing all this, I can go to my network. Come on. Yeah. go to my Astro Imaging 2 computer, because I had another one before. Open the drive that stuff is on. So here's today the 9th? Yeah, it's the 9th all night. Open up the 9th, and here's M110. So what I do is I open that up. Now this program here is the debearing program. That's where it takes the pictures. Well, I'll show you. This is what the picture comes out raw out of the camera. It's in grayscale, and you can probably see right there M110. And so what the debearing process does, as I understand it, and if I'm wrong, somebody can correct me. The debearing process adds the color information back into the picture, and as that's done. So now we'll stretch it again, and you can see that green background. So what we do is we do another program that takes that green background out. Now this is the background, what has been taken out, and you can look at that. You see it's all green. If there's different things going on here, then you know you've got something wrong, or something's affecting the picture, and I don't know what to do about it, but they say there's things you can do. So we'll unstretch that now and restretch it. And there's the picture. I think you can see M110 right here. And I'll try this one here. Yeah, now you can see it a little bit better. I'll darken the background a little bit. And bring up the saturation. Oh, I do that a lot. I'll bring up the saturation, and yeah, you can see it in there. And of course, taking 20 pictures and stacking them would make it come out much better indeed. So there you go. That's what I've had for tonight. In fact, actually, it's more than I'd planned on doing tonight. I'll do a walkthrough of PixInsight on how I use it. I mean, there's tons of videos out there on PixInsight that a lot of smarter people than me, but you might be interested, and I'll take that to you. Whoops. I think I'm going to just shrink this down because I'll probably process some pictures tonight. I did about an hour of the Western Veil last night, and it looked like it's going to turn out okay. So that's it. I thank you for watching, and like I say, any questions, comments, put them below, and I'll do what I can to answer them. Bye-bye for now.